All right, so today we start one of the biggest theorems in calculus called the fundamental theorem of calculus. I'm going to start with part 2 because part 2 helps you with finding definite integrals. So it's kind of a nice transition from the antiderivatives that we were doing yesterday, our last lesson. The fundamental theorem of calculus, and I'm going to abbreviate that as FTC from now on, specifies the relationship between two central operations of calculus, and that is differentiation and integration. The second part, sometimes called the second fundamental theorem of calculus, allows one to compute the definite integral of a function by using any one of its infinitely many antiderivatives. The fundamental theorem of calculus, part 2, states if f is continuous, and this is huge, that it has to be continuous in order to use this theorem, on closed interval a, b, then the integral from a to b of f of x dx is equal to the antiderivative with b substituted in, subtract the antiderivative of a substituted in. Again, f is the any antiderivative of f, that is the function such as f, capital F prime equals the integral f over there. This simply means to calculate the definite integral using FTC, find the antiderivative of f of x, substitute it in the values for b and a, and then find their difference. The result is the net area between the curve of y equals f of x and the x-axis between a and b. Note, when determining definite integral area, you do not need to calculate the constant of integration c. This is due to the fact that it would be eliminated when you subtract the two values for the upper and the lower limit. So I will actually do the first one with the c in it so that you can see the subtraction, but after that, it's not needed to put the c in there at all. It actually distracts away from the question. So we're going to do the first one. So FTC part 2 says basically find the antiderivative of 3x squared plus 1. So, and we use, we can use square brackets to indicate the antiderivative, and then we put still the upper limit and the lower limit beside it. I'll show you in a second here. So I'll give you a second to think, what is the antiderivative of 3x squared? So remember, we add 1 to the exponent and then divide by that. So that is x to the power of 3, and then the antiderivative of 1 is x. And I'm gonna put the c in there just to show you that the c's will subtract. And then after this first time, we're not going to do this anymore. Okay, so, and again, this is going from -1 to 3. So the lower limit is -1 and the upper limit is 3. So the fundamental theorem of calculus says if you were to find the antiderivative and then sub in the upper into the x and subtract the lower substituted in, you will get the actual area under the curve. So this would be 3 cubed, I'm going to put brackets for the first part, plus 3 plus c, subtract -1 cubed minus 1 plus c. So does everybody see? That's why I wanted to show you in this first example, that the c's are now going to be subtracted. Do you see? I have a c subtract a c. Do you see? They will cancel. So this is why we never actually put In the actual definite integral, when we're actually using FTC, we never put the c in there because it's just a distractor. So then we get 27 plus 3. Negative 1 cubed is a minus 1. But then we have a minus minus, so that's a plus 1. And a plus 1. You could also simplify the brackets first, then do the subtract. Anyways, 32. Okay, just for fun, put this into your calculator and verify that you do in fact get 32. You can pause the video and try that right now. All right, let's move on. So now we don't know how to do a product. There is no such thing as a product rule. So we need to actually do this multiplying before we can do anything. So x minus 2 times x plus 3 is x squared plus x minus 6 dx. Okay, so now, again, if you want, you can try this on your own, pause it, and then see what my result is. So add 1 to the exponent, so that is x to the power 3, and then you have to divide or multiply the reciprocal if you want. I'm gonna multiply the reciprocal, so 1/3 x cubed. Add 1 so to that exponent, so I get 2, and then I multiply the reciprocal, and then add 1 to 0, and you get x to the power 1. And so this is going from -1 to 2. So now I'm going to substitute it in. Bracket 1/3 times 2 cubed plus 1/2 times 2 squared minus 6 times 2. Subtract 1/3 times -1 cubed plus 1/2 times -1 squared minus 6 times -1. This time I'm going to actually come up with the individual brackets first. So I get 8/3, and then 4 times 1/2 is plus 2 minus 12. Subtract. Then I have 1/3 times -1 cubed, so that would be -1/3. -1 squared is plus 1, so I get plus 1/2, and then plus 6. So I think what I'm going to do now is I'm going to combine the whole numbers together and then the fractions together, because you'll see what something happens. So if I have an 8/3 and I'm subtracting -1/3, I think we're going to go back to basics and get rid of all the brackets here. So 8/3 plus 2 minus 12 plus 1/3 minus 1/2 minus 6. I'm distributing that subtraction to everything. So does everybody see when I add 8/3 and 1/3, I get 9/3, which is 3. So I have 3 and 2 is 5 minus 12 is, and I showed you this trick before, collect all the positives. So 3 and 2 is 5, a minus 12, and a minus 6 is a minus 18. And then I have this kind of lonely -1/2. So what's 5 minus 18? That would be -13 minus 1/2. So if you have both negatives, you're going to add them together, and you get -13.5, which is -27/2. That's your final answer. All right, so let's go on to the next example. So I'm going to write this over here. Remember, we always write the the square root as x to the power 1/2. So I'm going to write it as x to the power 1/2 dx. So the antiderivative, if you add 1, you get x to the power 3/2. Multiply by the reciprocal, you get the 2/3. And this is going from 1 to 9. So 2/3, 9 to the power 3/2, subtract 2/3, 1 to the power 3/2. So I would always square root first. So the square root of 9 is 3. 3 cubed is 27. So this is 2/3 times 27 minus the square root of 1 is 1. 1 cubed, so this is just minus 2/3. Because I know I have to subtract the 2/3, it probably doesn't do me any good to cross cancel the 3 and the 27. So I'm going to write this as 54 over 3, subtract 2 over 3 gives me 52 over 3. Again, if you want to pause the video and try the rest of the examples and then play it ahead, you are more than willing to do that. Do it. Okay, so the antiderivative of secant squared, of course, is tan x, and that's going from 0 to pi. Now, FTC Part 2 says this only works if it's continuous. Now, you need to check, is it continuous from 0 to pi over 4? Does anybody remember where it is discontinuous on a secant graph? That would be where cos is 0, right? So that's pi over 2. So if this would have been going from, say, 0 to pi, you couldn't actually use FTC Part 2. So tan of pi over 4, subtract tan of 0. So this is 1 minus 0, which is 1. Easy, right? Okay. Example 5. Antiderivative of cos x is sin x. This is the one that a lot of people will get confused. They forget whether it's a negative or not. Just find the derivative of sin x. What's the derivative of sin x? It's cos x. There's no sign change right there. So of pi over 4 to 0, or 0 to pi over 4. So this is sine of pi over 4, subtract sine of 0. So this is root 2 over 2 minus 0, which is root 2 over 2. All right, example 6. It says the integral from 1 to 4 of f of x dx, where f of x is that. Now you can see that it's split up between two functions. So that means we need to split up this integral. So this would be equal to, we can't go from 1 to 4 because it's not, well, first we'd have to check at 3, is it continuous? 3 goes in there, we get 3 squared, which is 9, and 3 goes into the second one and you get 6. So we know it's not continuous. So we need to split it up so that it is from 1 to 3 of f of x dx plus the integral from 3 to 4 of f of x dx. Now, does everybody understand that's the same thing as the integral of 1 to 4? Okay. So now when we sub in the function, it's going to be a different function based on the interval. So from 1 to 3, that is x squared. So this is 1 to 3 of x squared dx, plus from 3 to 4, that would be the second function. So this would be 2x dx. So the antiderivative of x squared would be 1/3 x cubed from 1 to 3, yes, plus add 1 and divide, so we get x squared from 3 to 4. So now we're going to do a bunch of subtracting. So 3 goes in, we get 1/3 times 3 cubed, subtract 1/3 times 1 cubed, plus 4 goes in there, 4 squared minus 3 squared. So this can cross cancel the first one. So this is 3 minus 1/3 plus 16 minus 9. So I would probably collect all the whole numbers. So 16, that's 19. 19 minus 9 is 10. 10 minus 1/3. So that is, let's make sure I have this all right. 3 and 16 is 19. 19 minus 9 is 10. Subtract 1/3. Okay, so we get 30 over 3. Subtract 1 over 3 gives me 29 over 3. Oh, I think somebody must have caught my mistake there. The 3 cubes 27, so 27 times 1/3 is 9. I knew I made a mistake there. I just had to pause to reflect. So this is 9 minus 1/3. The 9 and the 9 cancel. So we will fix that up. So we really have 16 minus 1/3. I think I showed you this trick. 16 minus 1/3 is 15 and 2/3. And 3 times 15 is 45, and 2 make 47 over 3 as my final answer. Sorry about that. Given that the antiderivative for 1 over x squared is negative 1 over x, calculate the derivative, the integral from negative 1 to 1 of 1 over x squared. So the problem now is that it's not continuous at 0. So we need to break this down. So this is negative actually let's calculate this on a calculator right now, and you'll see what happens. So get it out. We'll do the large screen here, and we are finding math 9, and we are doing 1 divided by x squared, comma, x, comma, it's going from negative 1 to 1. And you'll see what happens. Does everybody see you get an error? So I'm just going to put this on here for you. So I'm going to show you, if you don't catch that this isn't continuous, you'll actually go about your merry little way and actually figure it out. So watch this. So if I go from, and even if I split it up between negative 1 and 0, you'll still get dividing by 0, right? So I'll just show you that you can, in fact, calculate it in error, right? So this will give you negative 1 over x to the negative 1 to 1. So watch this when I plug this in. I get 1 goes in there, so I get negative 1 subtract. Negative 1 would be, you get plus 1, so you get negative 2 as your area, and you think, oh, that's one of the multiple choice. I must have done this right. Again, you cannot use FTC to calculate the antiderivative, like the definite integral, and actually get an answer. So you would say not possible to calculate, and I'll show you why. Does anybody remember what this graph looks like? If you were to find 1 over x squared is a parabola that looks like this, right? So if you were to do the 1 over, you know, little trick we learned in grade 11, grade 12, the ones, lower, upper. Do you see? So this is the graph of it. You have an asymptote at 0. So think about this logically. If I were to collect area under the curve, do you see at this spot right here, there's an infinite amount of area that you're collecting there because it never ends, right? It's not capped off there, so you can't actually find it. So you will get questions where that this is you can plug it in and get an answer and think, oh, well, everything's good. But what's going on is this is not possible to calculate discontinuous. You can write that. Okay. So next one, we have from 0 to pi of tan squared x. Again, if tan x is undefined at pi over 2, then tan squared x would be undefined. So again, this one is another one you have to catch. If you plug it into FTC and do it by hand, you'll get a number, but it doesn't make sense. It's not continuous. So watch for that if it's on the multiple choice, of course. Okay, let's go to the next one. We have the absolute value of x squared minus 4. So let's look at what that graph looks like. Remember, this is a parabola that got shifted upside down. So here's the parabola, and then the absolute value makes it reflected over like this. So does everybody see this is a piecewise function. We learned this in grade 11. That this is a piecewise function. So we need to actually split this into two different functions. So I will write it out. So note, the absolute value of x squared minus 4 is equal to two different functions. It's equal to the parabola x squared minus 4 when this is, of course, negative 2 and 2. So when x is less than or equal to negative 2, or x is greater than or equal to 2, you can decide where you want to put your equal sign. And then it's the reflection, so that means it's negative bracket x squared minus 4. If you want to write it out, this would be negative x squared plus 4. Think about that for a second. That is an upside down parabola at 4, so that makes sense why that would be the case. So that's when it's between negative 2 and 2. So that means I need to break this integral into that. So it's not just blindly plugging this into the FTC formula. You need to know what the function looks like. Although this is continuous, that means I can calculate it, but I need to use different functions based on different parts of the graph. So negative 1 to negative 2, I'm going to use, that's less than negative 2, so that's going to be x squared minus 4 dx plus, sorry, what am I doing? Try that again. From negative 1, it switches at 2, and so that would be the one that's in between. So this would be negative x squared plus 4 dx plus, and then from 2 to 3. Does everybody agree this is the same integral? So this is x squared minus 4 dx. So the antiderivative of negative x squared would be, add 1, so that's negative 1/3 x cubed plus 4x, and this is going from negative 1 to 2. And plus, same thing, 1/3 x cubed minus 4x, and that is from 2 to 3. So you can pause the video and figure it out. So I'll give you a second to do that. My final answer is 34 over 3. So make sure you can get that. You can use the space below. last question, it says find the area of the region between the curve and the x-axis bounded by the two given values. So you can see that it's from 4 to 6, so the integral from 4 to 6, and it is the function x squared minus 6x plus 9 dx. So pause the video and see if you can come up with the answer. So the antiderivative would be 1/3 x cubed minus 3x squared plus 9x from 4 to 6. So we get 6 cubed, which would be 216 over 3. I'm going to leave it like that because I know I'm going to get another over 3 answer just in case. So 6 goes in, 6 squared is 36. 36 times 3 is minus 108 plus 54, and then I'm going to subtract. 4 goes in, I get 64 over 3, minus 4 goes in, that's 16 times 3 is 48. 4 goes in, and I get plus 36. So 216 minus 64 all over 3 is 152 over 3. And then minus 108 plus that is minus 54. And this is minus 48 plus that is, now, so because this is a minus, minus 12, watch, this is a minus there, right? So this is going to be plus 12. So minus 54 plus 12 is minus 42. So this doesn't divide by 3, so I'm going to actually do the subtract. So 42 is 126 over 3. So 152 over 3 subtract 126 over 3 gives me 26 over 3. All right. And it looks like you have a textbook assignment. I also have from yesterday a circuit for antiderivatives for indefinite integrals. So you can have the remainder class to do the circuit together and then maybe do the textbook on your own time.